In this video, I'm going to talk about flags affected by addition and subtraction instruction. When executing arithmetic instructions, we often want to know something about the result. Is negative, positive, or zero? Or it is too big or too small to fit into the destination operand? So use these questions, we can detect calculation errors. Uh, and also we can use this knowledge to prevent the bad program behavior. To do this, we use CPU flag values mentioned in previous video. There's a E flag register which is 32 bits long like this. The first 16 bits used as flags. The first bit is called 0 bit location, is for carry flag. Whenever you add up two unsigned numbers, you produce the or carry. This bit location will be set to 1. If you have arithmetic calculation, your result is 0. This bit, 0 flag bit will be set to 1. So each of these bit here is very important to indicate the processing result. Okay, first let's talk about the carry flag. Carry flag is about when you're dealing with unsigned numbers. If you're adding up two numbers and the number result is too big to fit into the destination operand, and it's going to produce a carry, and the carry flag will be on. We have example here. We set up AR, we move AR with FF. This is the largest number you can put AR for unsigned. This is 255. So 255 is what you can put into 1 byte. If you add 0FF, that means you add 255 with 1. You're going to have 256. So 1 plus 1 is 2, 2 means 1, 0. So 1 plus 1 is 2, 2 means 1, 0. So all the way up, you're going to have 1, 0, 0, 0. AR only can hold 255. The result produces 256. So that's why we have a carry flag. It just means the result too big to fit into the destination. So after this add operation, your carry flag will be set to 1. Sometimes the subtraction also can cause the carry flag to be 1. For example, if you want to subtract a big number from a smaller number, and you're going to cause the carry flag to be 1. The book has this image. This is wrong, so don't follow this. It's wrong demo. Auxiliary carry is the flag indicates the carry or borrow out of bit 3. Okay, here we have example. This is bit 0 location, bit 1 location, bit 2 location, bit 3 location. So any bit if it carries out from here or borrows on top of this, is going to cause auxiliary flag to be 1. So this is example, and this is a carry. So this AC flag will be 1. Parity flag is set when the least significant byte of a destination operand has even numbers 1 bit. Okay, let's take a look. Here you start, you move AR with this number, and you have 3 ones in this binary number. And then you're going to add AR, that means this one with 1, 0, that means they add with 2. And finally, you're going to produce okay, here. So if you add this one with this one, this is your result in AL. You have 1, 2, 3, 4. You have 4 ones in here, and the parity flag will be 1. If you continue subtract AL, that means this result with this one, you produce this result. And in this result, you have 3 ones, and the parity flag will be cleared. A sign flag. It's said when the result of a sign arithmetic operation is negative. Here you move UX with 4, then you subtract UX with 5, you produce a negative 1 in UX, and this causes a sign flag to be 1. Okay. Okay, let's see how we can demonstrate the flag value changes through Visual Studio programs. I start my title, my comments, my library, my data segment. Then in my code segment, I start my main procedure, clear my screen, then print my message out. Then I do testing. First testing is testing carry flag. So I put the largest number can hold into air. Then I add air with 1, and this is going to cause carry flag to be on, because it cannot store more than FF there. So I use a code dump register to show the flag values. My second testing is about the 0 flag. I move 1 into BL, then I subtract BL with 1. This causes BL to be 0. So let me put here BL equals 0. And when the result is 0, the 0 flag will be set to be 1. And we're going to use the dump register to verify. My third one is testing about overflow flag. So I put the largest positive sign number into L. If I add 1 to it, it's going to cause overflow because it cannot fit into the destination operand. Then the next one I test out about the parity bit, parity flag. I move AR with this binary number. It has 3 ones in there. Then I add AR with 1. This is going to cause AR to be this much. I have even number of ones, so parity flag will be 1. Okay, same thing here. It's about the parity bit testing. I subtract AR with 1, cause AR to be this, and this is going to set parity flag to be 0. That means no more even numbers ones there. My last one is testing about the sign flag. I move AR with 4, then I subtract AR with 5. And this is going to cause AR to be negative 1, and this is going to set a sign flag to be 1. Let me test out this program. Okay, this is the result. We're going to compare one by one. Okay. For the first dump register, and I need to check the first one. Okay, let me see. Let me move up. My first one is about the carry flag. So the carry flag should be 1. Okay. So this carry flag is 1. That's right. My second one is about 0 flag. I have a 0 flag to be 1. So let me see. Second dump. 0 flag is 1. It's fine. My third one is testing about overflow flag. I produced the overflow, so my third one overflow flag will be 1. That's right. My fourth one, okay, my fourth one and the fifth one is all about the parity flag. One is on, one is off. Let me check out. Okay, the fourth one, Okay, this one. This is the fourth one, parity flag is on. The fifth one is subtraction, the parity flag is off. My last one is about sign flag. I put a sign flag. I have a negative value. I should have uh, a sign flag to be 1. So, so that's how we're testing out about the flag values. So I use a library function called dump registers. Thank you for watching.